Hello, this is the demonstration video of my MAT 501 project. I'm Kushagra, student number 240020, and my project is STIG, which is comparison of FSM and fuzzy logic in avoiding or in following a race line or a track while avoiding obstacles. This is the build application. Uh, and we can just launch the application by clicking on stig.exe. This is the main menu screen, and as we can see, it says click on track button to launch and see the system work in that track. And let's see how it works in track 3 with fuzzy logic. So by default, the obstacles will be disabled, so there are no obstacles the agent needs to deal with right now. Um, but we can see the front and left and right trigger boxes. So these are the inputs to the AI, and these are basically a box collider with trigger on them, and they are going to detect if they have collided with something, and then pass that information to the AI controller, whether it's FSM or fuzzy logic, and then that controller will then take care of that input and see if what it needs to do. So we will see the left collider just turned red because it collided with the left boundaries. Now the right did the same thing. If I turn on obstacles, we will see the front collider detected the collision, and then the agent is trying to avoid it. Uh, so yeah, it collided again, and then the left one turned green because the left one collided with the side collider. So AI know that I have obstacle in front of me, I have something in left of me. So I should calculate where I have more space, and then I should move according to the space I have. That's about it. That's how the AI is getting information from our input system. If I talk about environment more, so as soon as the AI crosses this red line, it's going to write this time value in a text file, which can be found in the main game folder. So this time.txt contains the value. This is from the last run. I should delete this. And we just ran for track 3, which was fuzzy logic track. The system was fuzzy logic, and it took 94 seconds with non-collision. So time is 134, which is 94 seconds. Select track 1 FSM, turn on obstacle, and this is how FSM actually avoid obstacles, and this is much slower than fuzzy logic, because fuzzy logic can uh, have both the move forward and avoid left states. So it can move forward with 70% of its speed and then turn with 30% of its effort. So there's that. Whereas in FSM, it's either going to move forward or going to turn left. There is no in between. And that's the main difference between these two methods, and the main reason why fuzzy logic is so faster than FSM in this task. If we turn obstacles off, both will perform exactly the same because both are now moving with all of their energy in the forward direction, and they don't need to deal with any sort of obstacles now. If I talk about the exact unity, so this is our track 1, and this is the fuzzy logic track. And if we see the main player, we have the fuzzy logic script, and we have the bounds, which is these three things, and they have a bounds script, which is basically the trigger checks. So on trigger enter, and if we are the front box collider, so the front one should have this Boolean tick. So if we are the front collider, we will say if we are colliding with the obstacle. So this tag is here, the obstacle. If we are colliding with obstacle, we're going to set our color to red to visually indicate that we are colliding with something, and we're going to set collision true so the controller can access if we are colliding with anything or not. And then we are going to set collider width equals to our colliding obstacle bound dot x size. Now this is being used by the FSM to calculate the shift distance, and we then call FSM's check obstacle function. Now in FSM, we have these four states. One idle, which is literally doesn't do anything, and move forward, just move the car in the forwards direction. The forward is negative of x, and avoid left is going to shift the car in the left direction. Left is negative of z, and right is positive of z, so it shifts the car in the right direction. If we go to move forward function, it's just transform.translate with the move speed, which is same for the fuzzy logic and the FSM, and then go in the negative of x, which is the forward direction for us. As we can see, red is x, negative of x is our forwards. For avoid left, we do the same thing, but in the left direction, which is negative of z for us. And we translate by shift distance. Now, shift distance, like I said, is being calculated using the collider width and the car width. So shift distance is the average of these two. This makes sure that we successfully avoid the obstacle and do not collide with it. Trigger box detects that we are in collision. We call this function check obstacles. And this function then checks if the left collider is in collision. So if left is colliding with anything or if right is colliding with anything, and what is the shift distance. Now, based on if left is colliding or if right is colliding, we select the state avoid left or avoid right. If both of them are in collision, we're going to go through the obstacle, we're going to take the collision, and we're going to complete the track with one collision. After translating, we see if the path is clear. If it is clear, we again move forwards. If it isn't, we're going to loop over this avoid left, and we can see that in our main handle state function. So if current state is avoid left, we're going to do avoid left, and if the path wasn't clear, the current state will not change. So we're going to call this avoid left again. That's how FSM works. So we start and move forward. Then if our trigger boxes give us any information which says, okay, you're colliding, we're going to go and say if we have space on left or right, and then we're going to shift and left or right. To keep the car on track, we have a waypoint system, and in the waypoint system, the car turns to or rotates in a way to align to these waypoints. These waypoints are all over the track, and they make this green racing line we are seeing, or this cyan racing line we are seeing. And the car is rotated towards these waypoints every 2 seconds. So if we see in the fixed update, if current time to rotate is greater than time to rotate, and if we are not avoiding, we rotate to these waypoints. This waypoint system is same in fuzzy logic as well. The main difference comes in how we are handling the input. So for fuzzy logic, instead of giving a collider width or calculating a shift distance, we are passing the other game object or the obstacle we collided with as the obstacle to fuzzy logic controller. And then the fuzzy logic controller starts in our fixed update by calculating the distance to the obstacle and the left space and right space if there are any obstacle in left and right. And then we fuzzify these inputs based on trapezoidal membership functions. I have more detail on these functions in the report. And then we check if we are already avoiding any obstacle. So is committed logic is there to check if we are already avoiding, because if we are already avoiding, we do not want to uh, confuse the system by giving new values and then telling it to avoid in a different direction. So if you're already avoiding, then just skip everything. If we are not already avoiding, we check if I have more space on the left or the right. And then based on that, we calculate the value for turn, which is our main variable which controls how much turn we want. There's also speed, which is again the fuzzification of our distance and slow and fast rules. So if the distance is far, we are going fast, and if the distance is close, we are just stopping and then turning. In our move car function, we are applying these turn and speed. So the turn speed is 5, I think, and move speed is 10, which is same as FSM. When the car detects that there is a obstacle, so now it detects there is an obstacle, and if it's far away, we just go into speed, and then if it's close enough, we do not go at high speed, but we turn very quickly. So if we see the turn and speed, so turn is 0, we do not detect anything. And if we are really close, the speed becomes 0. So if we see now, the speed will come to 0 almost, and then turn will take over. And this is the reason why fuzzy logic is much, much quicker than FSM. In the results section of the report, you'll see that fuzzy logic is about 50% quicker than FSM, because FSM just stays there and tries to shift and avoid the obstacle while doing nothing, whereas fuzzy logic can move forwards and turn at the same time. For the data recording, as soon as both of the system crosses the finish line, so when they exit the finish line collider, we write the time value to a text file, and that text file is called time.txt, and it should be placed in the main folder. So if we open up time.txt, we have the file with the last value we wrote to it. There's also result.txt, which contains all of the values from the testing, and these are average of 3 runs, and these are also used in order to plot the graphs in the report. There are few cases where AI struggles, especially in track three. So near this penultimate bend, the AI will get stuck onto an obstacle. So here it just detects that there's an obstacle. Then it detected that there was space on the left, but then it fails to detect that now I'm stuck in the left collider. However, it then free himself without any intervention. So after a certain period of time, it realizes that it has stuck in that corner. This thing costed a few seconds, and that's why it's much more slower on track three than fuzzy logic. Other breaking scenario is because of the rotation system or the waypoint system. So we rotate every 2 seconds, but that rotation is just dependent on time and if we are avoiding anything. The car is fine, it's avoiding every obstacle, and I'm sure that if it can detect that obstacle, it will avoid it. But as we see that if we are near a waypoint, actually, we then rotates to the next one, and now near this waypoint, we will rotate and then collide into an obstacle because the obstacle is placed in a way that it's right behind the car and it doesn't detect it. This should be the one. Yes, and we see that we have collided with an obstacle. So it came to this waypoint, and the obstacle was right behind it, or right on the right of it. It was on the right of it, and when it came to this waypoint, it rotated towards the left direction, and it didn't realize the back of the car will then collide with the obstacle. So that's another breaking case, and this can easily be addressed by placing the waypoint in a way that it's not near the obstacle, or making sure that when we're rotating our new position is not colliding with the obstacle. That is it for my project. I have compared FSM and fuzzy logic, and fuzzy logic is much better at avoiding obstacles. However, FSM and fuzzy logic perform the same when there are no obstacles. So if the track is simple and if there are no obstacles to deal with, then I would recommend using FSM because it's going to be easier to implement and computationally less expensive, whereas fuzzy logic will be much more better when it comes to avoiding obstacles and it's still following a race line. Thank you for watching, and let me know if there are any more points I should share.